Hello viewers, in today's session we are going to discuss an important problem from limits involving greatest integer function, and here we have to see whether the limit of this greatest integer function, that is greatest integer of 2x minus 3, when a limit x tends to 1, whether this limit exists or not, right? So here what we will do, we'll first find out the right hand limit and then the left hand limit, and if both the limits are equal to each other, then we can easily claim that the limit of this function exists, right? So let us first find the right hand limit. So let us first take this greatest integer of 2x minus 3 as f of x. So we have this function and we have to see whether the limit of this function when x tends to 1, it exists or not. So the notation for the right hand limit is given by limit x tends to 1, and here we put a positive sign, and here we have f of x, right? So here we'll take x is equal to 1 plus h, where this h is infinitesimally very small and h is a positive quantity and it lies between 0 and 1. So when x tends to 1, from the right of x is equal to 1, then h tends to 0. So here we have the real number line, and here we have 1, and here we take a point in the neighborhood of x is equal to 1, and this point is 1 plus h. So while finding out the right hand limit, we take a point in the neighborhood of x is equal to 1, which lies towards the right of x is equal to 1. And when we find out the left hand limit, then we take a point towards the left of x is equal to 1, and this point is 1 minus h. So now the right hand limit, it can be written as limit h tends to 0, because when x tends to 1, then h tends to 0, and we have f of x, and x can be replaced by 1 plus h. So now the value of f of 1 plus h can be obtained by replacing x by 1 plus h. So we have greatest integer of 2 times 1 plus h minus 3. So let us simplify it. We have here 2 times 1 is 2, then we have 2h minus 3, and we can now write limit h tends to 0, and here we have 2h, and 2 minus 3 is minus 1. So whenever we come across with functions like greatest integer function, we cannot directly substitute here h is equal to 0, right? So we'll first make use of the definition of greatest integer function, right? So let us first quickly see the definition of greatest integer function. Now consider a real number x, and if we have x greater than or equal to n but less than n plus 1, where n is some integer, then the greatest integer of x is equal to n, right? For example, if we have greatest integer of say 2.3, then the value of greatest integer of 2.3 is equal to 2, because 2.3 is greater than 2, but it is less than 2 plus 1, that is 3, right? And similarly, if we have say minus 2.3, then the greatest integer of minus 2.3 is equal to minus 3, because minus 2.3 is greater than minus 3, but it is less than minus 2. So now with the help of the definition of greatest integer function, we have to assign a value to this expression, that is greatest integer of 2h minus 1. So for this we have to make use of this inequality, that is this quantity h is a very small quantity, that is infinitesimally very small, but it lies between 0 and 1. So when h lies between 0 and 1 and it is infinitesimally very small, then the value of 2h should also lie between 0 and 1, right? And here we have 2h minus 1. So if we subtract 1 throughout this inequality, then we have 0 minus 1, and here we have 2h minus 1, and here we have 1 minus 1. So this is minus 1, this is 2h minus 1, and this is 0. So now a 2h minus 1, it lies between minus 1 and 0. So here we have the real number line, here we have 0, and here we have minus 1. So this quantity 2h minus 1, it lies somewhere between minus 1 and 0. So by definition of greatest integer function, the value of greatest integer of 2h minus 1 should be equal to minus 1. So here we have limit h tends to 0. Greatest integer of 2h minus 1 is limit h tends to 0, and for greatest integer of 2h minus 1 we can write minus 1. Now this term is independent of h, so the limit is simply equal to minus 1. So the right hand limit of this function when x approaches to 1 is minus 1. So here we have a right hand limit equal to minus 1. So let us now find out the left hand limit. Now the notation for the left hand limit is given by limit x tends to 1, and here we put a negative sign which shows that now we are approaching towards x is equal to 1 from the left of x is equal to 1. So here we have f of x. So now we make this substitution, that is x is equal to 1 minus h. Now 1 minus h implies that we have to consider all values of x which are less than 1, right? And other conditions remains the same. So when x tends to 1 from the left of x is equal to 1, then h tends to 0. So now we have limit h tends to 0, and here we have f of x. X is 1 minus h. So now we can write limit h tends to 0, and f of 1 minus h can be obtained by replacing x by 1 minus h. So we have 2 times 1 minus h, and here we have minus 3. So let us simplify it. So we have now 2 minus 2h minus 3, and this is the limit h tends to 0, and we have 2 minus 3 is minus 1, so we have minus 2h minus 1. So now our aim is to assign value to greatest integer of minus 2h minus 1 again by using this is the inequality, that is h lying between 0 and 1. So now h lies between 0 and 1. So 2h should also lie between 0 and 1. Now here we have minus 2h minus 1. So let us add throughout 1. So we have 0 plus 1, here we have 2h plus 1, and here we have 1 plus 1. So we have 1, here we have 2h plus 1, and here 1 plus 1 is 2. Now 2h plus 1, it lies between 1 and 2. But here we have a negative of 2h minus 1. So what we can do here, we can write limit h tends to 0, greatest integer of negative of 2h plus 1. So now if we multiply throughout by minus 1, then we have minus 1 minus 2h plus 1, and here we have minus 2. But the direction of the inequality get reversed. So we have here minus 2h plus 1, here we have minus 1, and here we have minus 2. So we can also write this inequality as minus 2 is less than minus 2h plus 1, and this is further less than minus 1. So minus 2h plus 1, it lies between minus 2 and minus 1. So here we have the real number line, and here we have minus 1, and here we have minus 2. So minus 2h plus 1, it lies somewhere between minus 2 and minus 1. So the greatest integer of minus 2h plus 1 should be equal to minus 2 due to this definition. So here we have minus 2. So now the left hand limit is equal to a limit h tends to 0, and for greatest integer of minus 2h plus 1 we have minus 2. So here we have simply minus 2 because this term is independent of h. So the left hand limit of this function when x approaches to 1 is equal to minus 2. So now from this discussion, we have arrived at the conclusion that the right hand limit is equal to minus 1 and the left hand limit is equal to minus 2. And here, although the right hand limit and left hand limit both exist and they are finite, but they are not converging to the common value, right? So this implies that right hand limit is not equal to the left hand limit, because for the existence of limit of a function, the right hand limit should be equal to left hand limit. But in this case, the right hand limit is minus 1 and the left hand limit is minus 2, and minus 1 is not equal to minus 2. So we can safely claim that the limit of this function when x approaches to 1, it does not exist.